Hello and welcome to the Writing Exponential Equations video. In this video, I'm going to show you two different methods of how to write an exponential equation from 2 points or essentially a graph. If you're given a graph, find 2 points, then use these methods. First, we need to know what type of equation are we using. In our story problems, we had so many different types of equations. Well, we're going to be using the one we didn't actually really use in our story problems, which is y is equal to a times b to the x. In this case, x and y are just x and y values from our points, but our a value, you can think of that as kind of like the start of your function or the y-intercept if we were looking at a graph. And the b value, well, we see it's multiplying there. If we think of like a linear function with a slope, we're adding something each time or we're subtracting something each time. So maybe we're adding 2 to every y value or subtracting 2. In this case, our pattern here, I'm going to call this our multiplier, because for an exponential function, instead of adding 2 or subtracting 2, we might be multiplying by 2 each time or dividing by 2. So it's going to be our multiplier. You may also hear this as the common ratio as well, but you'll be hearing me say multiplier. So when we get started, I'm actually going to start with example 9 over here. So example 9 says, find an algebraic rule or formula for an exponential function. So again, just a reminder, exponential function is a multiplying pattern. So write a rule or formula for an exponential function, f, that passes through the points 1, 8, and 3, 128. So I'm going to zoom in here really quick for us. There we go. So let's see, we have x and y, we have x and y. Now, one of the methods we could use is to actually like almost make a table and just leave a bunch of gaps. So if I was to make a table, I'm going to do a sideways table. I know when my x value is 1, my y value is 8. When my x value is 2, don't really know what's happening, so I'm going to leave that blank. And when my y value is, when my x value is 3, my y value is 128. Now, I don't know what I have to multiply by each time to get to 128, but I do know that I have to multiply by something. Let's call it b. And then from the y value of 2, I need to multiply by that same b value again to get to 128. So the way we can think about this is that, like, hey, 8 times some b value times that same b value, that's going to get me to 128. That's because we have this multiplying pattern. Another way we can write this is that 8 times b squared gets us to 128. And now I can solve for b. So I'm going to divide both sides by 8 and get that b squared is equal to 16. And then I'm going to square root both sides. We get that b is equal to 4. In these cases here, when we're solving, I'm going to have you just always grab the positive version of the answer. I know technically negative 4 is also the square root of 16, but any negatives that will pop up will be in our a values. So we'll look into that in a little bit. So just a reminder, always take the positive version. So when we're writing exponential equations, always take that positive version. So now that we have our b value in our equation, which just a reminder is y is equal to a times b to the x, well, I have my b value, and I have 2 different x and y values to choose from. So I'm going to take this b value and plug it into one of the equations. So we have, as of right now, y is equal to a times our b value of 4 to the x. So it's up to us to pick, hey, which x and y value do we want? You can really pick either point. However, I'm going to choose the point 1, 8 just because it's smaller numbers. So we're going to have 8 is equal to a times 4 to the power of 1. Or another way to write that is 8 is equal to 4a I'm going to divide both sides by 4 and get a is equal to 2. So overall, my final answer here is y is equal to my a value of 2 times my b value of 4 to the power of x. So this is just one of the methods you can use. Making a table, finding that b value, plugging that back in, and finding your a value. Now, for our second version that we're going to do, the only thing that's different is the finding of this b value here. To find your a value, you're always going to plug your b value into some setup of the equation and solve. But the only difference is here in our setup. So instead of making a table, we're going to be using systems of equations. But it's going to be slightly different than what we remember. So if we move up to example number 8, it asks us a similar question. Find the algebraic formula or rule for the exponential function that passes through the points -2 3/4, so that's an x and y, and 212. So that's an x and y. So you can definitely still make a table here if you want to find your b value, but -2 and +2 are a little bit farther apart. So instead, I might set up a system of equations. So I don't know my a value, I don't know my b value, but I do know 2 values of x and y. So I am going to plug those in to my equation. Now, it doesn't necessarily matter which order you do this in. However, it's going to be very beneficial to put the equation with the higher exponent on top. So I'm going to make a note about that. Put equation with the higher exponent, or you can think of that as your x value, on top. You're still going to get the same answer whichever equation you put on top, but if you put the equation with the higher x value or exponent on top, it's going to make life much easier for you. So when we set this up, we will have 12 is equal to a times b to the power of 2, so we've plugged in our x and y, and we're going to have 3/4 is equal to a times b to the -2. So this is what I mean by on top, is we're putting one equation set up on top of the other. Now, in systems of equations, for instance, if we had something like 2x minus 7y is equal to 3 and x plus 4y is equal to 10, we would multiply this bottom one right here, and then we would subtract the equations, right? Or we would add the equations together, something like that. Well, with these equations here, that's because our pattern is adding or subtracting. But here, since our equations are multiplying together, the opposite of multiplying is dividing. So just like how we would subtract these equations to get rid of one of the variables and solve, here I'm going to do the same thing, except now I'm going to divide my functions. Now, when I'm dividing these functions, the answer I'm always going to be able to get rid of is a, because even though I don't know what a is, I know that a divided by a, or anything divided by itself, is always going to give us 1. So we can always cancel that out. And our b values, one of the reasons we might want the highest b value or the highest exponent on top, is because when I have two numbers of the same base being divided by each other, I can subtract their exponents. So if I subtract the exponents here, I get 2 minus a -2, which is going to give us b to the power of 4. If you put b to the power of -2 as your top equation, you'll end up with b to the power of -4, which isn't a bad thing. We just then have to deal with negative exponents. This might be a little bit easier. So we've canceled out our a's, we have our b's, and then we have 12 divided by 3/4. You can do this in 2 steps. You can grab your calculator and do this in 1, but you should get the answer of 16. So now we have b to the power of 4 is equal to 16, and then from here we can take the 4th root, or we can also put this to the power of 1/4. We're going to get the same answer either way. And we get that our b value is equal to 2. Again, just a reminder, you're always going to want that positive version. I am aware that -2 is also a 4th root of 16. So now that we have our b value, I'm going to take that and plug that in to one of these equations here. Again, you can choose any equation or any of these equations that you want, but I'm probably going to pick the one with the positive exponent just to make my life a little bit easier. So this is 12 is equal to a times 2 to the power of 2. Well, we can rewrite this as 12 is equal to 4a. Once I divide both sides by 4, I get a is equal to 3. So when I write my final equation, I can say that y is equal to 3 times 2 to the power of x. And that is my equation. So, like you can see, there's two different methods, slightly similar, slightly different, in order to write exponential equations. If you have any questions, please let me know. I look forward to seeing you in class.